Next problem, example B. If you notice, it's not in the correct form. I have the x squared as positive 1, but I don't have this equal to 0. I have it equal to negative 16. So what I want to do is I want to add 16 to both sides. When I do that, I can copy the x squared plus 8x down, and then I'm going to have this plus 16 is equal to 0. I've done my step 1 now. I have this equal to ax squared plus bx plus c equals 0. From here, I need to figure out which factoring method I need to use. I'm going to tell you right now, this one is a perfect square trinomial. And here's the way that you know that. It's not a greatest common factor because these don't have anything in common. I can't make one smaller. They don't all have a variable of x. Perfect square trinomial because if we pretend this is a 1, 1's a perfect square and 16's a perfect square. This would break down to be x times x makes x squared. This would break down to 4 times 4 makes 16. 4 times x would make 4x, which is half of 8. Remember, we have to look for that half with a perfect square trinomial. This problem is going to look a little bit different in your answer. And the reason is because when we have a perfect square trinomial, if you remember, our parenthesis is doubled up exactly, meaning that I have 2 x's here and 2 positive 4's here. So I could write this as x plus 4 and then x plus 4. But if you remember, there's a shortcut to writing this because they're identical. I could just write this as x plus 4 squared. This kind of problem, because I only have one expression inside of parentheses, I'm only going to get one answer when I set it equal to 0 later on. I can just think about this as x plus 4 is equal to 0, because if I did it twice, it's going to be the exact same thing. And I'm doing this because I'm doing what we did up here, taking it and having it set equal to 0 like we did up here. When I solve this, I get x is just equal to negative 4, which to me sounds like when we go to solve this, if we had a graph for a parabola and the only place it's crossing is at negative 4 here, I'm willing to bet that means that the parabola is going to open up like this because it's only crossing or touching at one point. So our parabola is going to look something like this if we were to graph this. That's how you would do a perfect square trinomial.